Hey everybody, Bob Zink here. I'm the owner of Red Mountain Engraving, small laser engraving business that I started back in 2020. I just wanted to give you guys a quick overview of an upgrade that I made to my machine here. This will probably be of interest to most of the people in this group and some others, but what I've got here is an HL laser cut Chinese 1060 100 watt glass tube laser. Now, this machine comes with the Ruida controller. It has the G model controller. It originally came with two NEMA 17 stepper motors, one that controlled your X-axis and then one controlled the Y down here. This machine does have a Z-axis controlling the bed up and down. And it did come with a rotary that you see in here. And originally I had it so you had to unplug the Y every time you went to go run a job for the rotary. Royal pain in the butt, and then you had to somehow figure out a way to keep the Y-axis from moving, so I had to pin it in place, and if it moved on you, your job was shot. You lost what you're doing. So I've been working on this for a year, and I've done several upgrades to it. I'll go through them quickly here. I don't want to have this be too long of a video, but I was getting really kind of fed up with the machine. I had spent a little over $3,500 on the machine, I think, and that was delivered. About $4,000 total, probably, with delivery, and it was decent for the money for what I was doing with it. Some smaller jobs, but as I started to get 100, 200 orders at a time, minutes take hours longer for the job total. So I wanted to speed this up, make it more reliable. So what I did was the first thing that I worked on here is I noticed when I was engraving, I got a lot of left to right slop, meaning the X-axis here, as it traveled, you'd get it actually moving. This would move slightly, about 1 millimeter to 2 millimeters, depending how fast you're running it, and your engraving would be off by quite a bit. So anything over 400, 500 millimeters a second, I couldn't get anything accurate out of. It was just, really heating the motors up and just running slow, or running too fast, rather, and skipping steps and just inaccurate. So what I did was I went ahead and upgraded. The first thing I did was upgrade the Y rails. So these are now, instead of the metal tube style that kind of just slide back and forth in here, that would, once you got in the middle, it would really start to move left to right on your X on an engraving. So these now have two heavy-duty linear rails that are lifted up with some aluminum spacers so that I can get some clearance in here. And both sides run these heavy-duty blocks with grease fittings that are mounted to the original X-axis rail. And the X-axis rail has the same linear guide on it that came with the machine. And you can see I kind of fabric cobbled a mount here together out of some plexiglass that I had. That's going to be upgraded. This is all kind of a test platform. But the biggest upgrade here is this over here. So this motor, our X-axis motor, which was a NEMA 17, has been yanked out and replaced with a Leadshine NEMA 23 hybrid servo motor controlling the X. And then down here on the Y-axis, I've upgraded this to a NEMA 23, standard NEMA 23 for the Y. That's a dual-sided, goes through and controls the Y-axis on this side, and then the rod that comes with the machine comes over to here to keep it in sync. Definitely made a huge improvement with this. The other thing that we upgraded on this machine is the tube holders. So I took those crappy metal ones that you can see in there and bypassed them, had to lift it up anyway, and use the Cloud Ray ones that are in there now. You'll see it's got a Cloud Ray first, second, and third mirrors here, and a Cloud Ray adjustable tube. You can see here, if I push on this X as hard as I can, it's not budging at all. I'm trying to move it. Same thing with the Y. I'm pulling and pushing and it's just not moving. So, definitely a lot stronger. The thing I was trying to improve was accuracy and speed. So, I'm going to run this job here. You'll see I'm running a rotary that came with it on the U-axis here on the controller. So as I hit those buttons, you'll see the rotary moves. But I can also move the y-axis and the x-axis. So I can home it to where I need to in order to get it without having to have that laser head in the way every time I'm reloading a bottle. So the only trick to this is the G board, the G model board that's in this HL laser cut machine, does not allow you to send a rotary job to the machine on the U-axis from Lightburn. So you have to save the job, send it over to the machine, and then run it off the machine, which is fine. You know, honestly, it's more stable of a connection, especially if you're doing 100 bottles like this or something. Anyway, you don't want to have that happening where you're having to come back and hit the button every time. You just want to be able to hit start and go. So the cool thing about this is it is super fast and super accurate and way better than it was before. I'd put this in comparable to some of the more expensive machines like Thunder Laser and all those. And I probably have about $500 to $600 into this total upgrade between the linear rails, the motors, and some other parts and pieces that I've upgraded, including the laser mirrors and everything else. You can see I've upgraded the outside here to a larger 8-inch diameter exhaust fan that is shared with my fiber laser. And the goal of this was to try and be able to speed up these jobs. Obviously, time is money when you're doing a batch of 100, so I wanted to try and get what I could out of this machine without having to spend another $10,000 or $15,000 on an Epilog or something like that. So I'm going to go ahead and run this and show you guys how this works. So we're starting off from the docking position from home. I'm going to go ahead and hit start on the controller. And you can see here, she is cranking. So we're currently running at 850 millimeters a second, 38% power, and this thing is just moving. And you can see on the X to Y rail, there's no movement, zero. If I ran this job, it first would skip steps, but secondly, it would also just shake this machine to the point where it's ready to explode. You can see my hands just sitting here, nothing. So this job, which normally takes about 9 minutes on the other, before I upgraded it, is now running, like I said, 850 millimeters a second. I can get it to go faster, but it starts to really go crazy, and I'm going to lighten that head up and make it more like the Epilog lasers, really lightweight, compact. But basically, that's the hold up right now, is the weight of the head. So this job, like I said, normally takes 9 minutes or so, probably 5 minutes 50 seconds on my fiber laser with a rotary. And I'll show you in Lightburn here, the same job I just ran. And you can see we got, well, it doesn't give me the previous job here, but it normally would say 3 minutes, 2 seconds. So 9 minutes and 3 minutes, 2 seconds. So I'll give you guys some more updates if you want. Just post in the comments and let me know if you have any questions. I can give you a list of what I bought and how much it costs and how I did it. You know, it's quite a process. It took me about a year to do it on and off, but definitely worth the money, worth the time.